All right. Okay. So we're gonna do number 1 first. So I'm just gonna draw them up here. What I want you to do now is to fill in like the values of the resistors on your sheet, so it's like below them. Put them actually on the diagram.
Hi, bro. What up, my altar girl?
Hi, boy.
Tacos.
Okay. So are these 3 resistors in series or parallel?
Parallel.
Parallel. Why parallel? There's 3 different paths, so all 3 of them are in parallel. What do we do when they're in parallel to find the total resistance? Do you remember the equation for that? Is it
1 over 1.
the 1 over 1. So it's going to be 1 over the total resistance equals 1 over 10 ohms plus 1 over 21 ohms plus 1 over 15 ohms. Alright, do not try to do fractions, you'll drive yourself crazy. Does that make sense? So put those fractions in the calculator, and then make sure you don't forget to do 1 over the answer. So it's going to be 1 over 10 plus 1 over 21 plus 1 over 15. And so 1 over RT is going to equal 0.214. Now we got to take the reciprocal of that. If you get a decimal answer, it's possible to get a decimal answer that's right, but it probably means you forgot to take the reciprocal of it. Does that make sense? So if you get a decimal, make sure you're probably going to do 1 over it. So you're going to do 1 over 0.214 to get RT. So 1 divided by that is 4.67 ohms for our total resistance. Does that make sense to everybody?
All you do is 1 over that.
From step 2 to 3.
How did I go from step 2 to 3?
Yeah.
I did. So RT equals 1 over 0.214. Does that make sense?
Yeah.
So when you get to this step, you just do 1 over this answer over here. Does that make sense? Do you want me to show you the algebra? Yeah. Yeah? Okay, so what you're doing here,
Just
I put it up, just give me 1 second, guys. So we're going to multiply both sides by RT, so it's going to be 1 equals 0.214 times RT, and then we get 1 over 0.214 equals RT. Does that make sense now?
Yeah.
Chloe?
Okay, can we use the just math, like
Can we use the fraction function in our
So
calculator?
then we get 3/14 and take the reciprocal and 14/3, which is equal to 4.67.
I want to make sure you have a decimal answer.
Okay.
I don't want your answer in fractions. Okay,
Why not?
because fractions have an infinite number of significant figures, which are bad in science.
Do you always want 2 significant figures or like 3?
Same thing.
Usually want whatever you had in the most of the problem, but don't worry about it for this for right now. Okay, so now, everybody understand how we found the total resistance?
Yeah.
Yes, sir.
Okay, what we're going to do is, now V equals IR to find the current. What's our voltage going to be? 3 volts. Current is I, and our resistance is whatever the total resistance was, so 4.67. So divide that out, we get the total current in the circuit, I'll just call that IT, is equal to 0.64, what's the unit for current? Amps, so A. Any questions on that one?
On to the next.
Alright, can I erase this?
Do it.
Very.
Alright, we'll do the next one together as well.
Can we have like commercial breaks on
Alright, are these next one, is it in series or parallel? Series, because there's only one path through.
Why don't I this?
I can't even read.
What's up with
Bo drizzle.
Okay. So these are in series, so how are we going to find the total resistance? Add them up. So our total resistance for this one is going to equal 22 ohms plus 15 ohms plus 10 ohms. So what's that add up to?
27.
27 ohms. Okay. Now we do V equals IR. What's our voltage for this one? 15, just the voltage of the battery. 15 volts equals I times 47 ohms.
about 0.78?
And our total current in this one is
0.78. I got that right away. Died.
0.32 amps.
Michael.
Alright,
Alright. Everybody okay with this one? This one is pretty straightforward.
Oh, I get it now.
Yes.
On the worksheet, when it says, like number 1 says find the total resistance, and number 2 says find the equivalent resistance, what's the difference?
Total resistance and equivalent resistance mean the same thing.
Okay.
So if you see total or equivalent, that's why I put them both on there, so you get used to both. So total and equivalent resistance means the same thing.
Mr. Tente, your circuits look really good.
Thank you.
We're
I've
actually
done them a
wiring
lot.
them right now.
What?
We're wiring them right now.
Like you're
Straight lines and everything.
Okay.
He's drawn a few circuits. I don't see that straight edge. Or the purple one.
I've drawn a couple circuits in my day, like Ellie said. Okay. This one is a combination of series and parallel. What are these two? Are they in series or parallel with each other?
Parallel.
Parallel. This one, 14 and 16 are in parallel with each other. There's two paths through that part, so it can go through one or the other, not both. Does that make sense to everybody?
Yes.
Alright, what about this whole thing in the 21? Are they in series or parallel with each other? Series. So what we're going to solve this one in parallel, and then solve this one and this one in series. So first thing we're going to find is, this is R2, and R3, and R1. So we're going to find the total resistance of R2 and 3 in parallel, and then find the resistance of everything in series. So first thing we're going to do R, we're going to call this R2, 3. And we're going to use the 1 over thing or just the addition thing? 1 over. 1 over. So we're going to use reciprocal ones. The 1 over R23 equals 1 over R2, which is 14 ohms, plus 1 over R3, which is 16 ohms. So when we work that out, what do we get?
7.47.
7.47. What's the unit? Ohms. No. Okay. Questions about how we get that? Okay, it does look like a horseshoe. It is the Greek symbol omega, though.
I know.
So you're both right, I guess. Alright, so now, to find RT, we're going to take this number, because it's in series with this one, and add them together. So it's going to be 7.47 ohms plus 21 ohms, and what's RT equal?
36.
28.47 ohms. Any questions on that? Alright, last step is V equals IR to find our current. So our voltage is 36 volts. I is our current, which we're looking for, and 28.47 ohms is our resistance. So we divide that out, we should get IT equals 1.26 amps.
I'm so amped right now.
Alright, questions on that one?
That felt really good.
Alright, you guys doing okay with this so far?
Yeah, that's fun.
One other thing I want to mention is you always work kind of from the inside out. So you solve like the individual pieces before you solve the whole thing. So let's say this one was looked like this. So if it had 2 up there instead, we would solve for these 2, then this whole thing in parallel, then this whole thing, and this in series.
One more time.
So would you add those two together
Add these 2 together,
and then do the resistor thing?
then do the 1 over thing for this part,
Great.
then take this whole answer and add it to this one.
Okay, bro.
Does that make sense how that would go? Alright, you guys want to do 4 together?
Yes.
Okay. Alright, I'm going to draw it out a little differently here. Okay, can I erase the work over here? Probably should have not started erasing before I asked.
That into the clicks of that.
Okay. 8 ohms, 19 ohms, 18 ohms, 25 ohms, 16 ohms. Okay.
25 and
Yeah,
16
I do.
reversed, does that matter?
Oh, it doesn't, but I should do it, draw it correctly. 16 ohms on top, 25 ohms on bottom. Okay, so you see I just drew it a little differently. Do you see how there's R1 and R2 are still in parallel? That's R1, R2, R3, R4, that's R5 though, isn't it? And then R4. Okay, so how are we going to solve this one?
You do the 2 parallels and then you add all 3,
Yep.
and then you solve for it. Yeah.
So we're going to do this one in parallel, this one in parallel, find those 2 answers, add the parallel for this one, plus the parallel for this one, or plus this one, plus the parallel for this one. Does that make sense? So while you guys are doing that on your own, I'm going to write the correct answer up on the board while you're doing that, and then if you need me to, I can explain it in a second here.
you got the unit
I wouldn't do that. And if it's like sub-zero, I would.
Okay, anybody have any questions over anything I did up there? Alright, how do you guys feel about this right now?
Good.
Good? Alright, well you guys start working on the back. And I'm gonna cut off the videos, and if you're a CJ kid watching this, feel free to post any questions you have on Edmodo, and I or somebody will try to answer it.
on our next installment.
Thank you, Sarah.
Have a great day.
Show me your
Bye.
Bye.